Hello students. So today we are going to start with our subject Science Standard 6, lesson number 11, Work and Energy. So let us begin with the first half of our lesson. Okay students, so I'll show you some pictures. This very first picture, we can see that this girl is trying to pull a bag. Correct? She's pulling a bag. Now moving to the next picture, we can see here the boy is playing with a wheel hoop. He's playing a wheel hoop. Correct? Now moving to the third picture, we can see this person is hammering a nail. He is hammering a nail into a wooden plank. Now fourth picture, we can see that this boy is trying to pull one box and taking it somewhere else. Now next picture, we can see this man is carrying a log and taking it to some place different from one place to another. Correct? Now next picture, we can see that this girl is trying to play with a bow and arrow. So students, in this all about pictures, we have seen that the position of some of the objects has changed. Correct? Someone is taking the bag from one place to another, someone is pushing the wheel from one place to another, someone is hammering the nail which is up and the nail is now going inside, somebody is pulling the bag, someone is carrying a log, someone is throwing an arrow. So these all are showing the possible changes in the position of the object. So students, basically when an object is displaced by applying a force on it, work is said to be done. Now let's study about work. What is work and how you can understand work, I'll let you know. So what you have to do is you have to tie a string to an empty box as shown in this picture. Now pull the box through a distance of almost 10 meters along a straight line. Now after that, what you have to do is fill the same box with 20 books. Now this box is heavy. Now pull the box again through a distance of 10 meters in a straight line. What was your experience this time? You find it that it was little heavy. The one which you carried with an empty box, that was easier, but this was little heavy, but still you maintained it. Correct? You managed to pull it. Now what you have to do, now pull this loaded box through a straight distance of 20 meters. Now you have to pull this box to a straight 20 meters. Now when did you feel the more work was done? Now first 10 meters was okay, but now you have to carry it till 20 meters. So from this it is very much understood that up till 20 meters you felt that you did more work than the 10 meters one. Correct? So basically more work is done for the same displacement when more force is applied to do the work. If the same force is applied for more displacement, more work is done by the force. So students, from this we understood how work and force are interrelated and how displacement help in this. Now again, let us try. What you have to do is you have to take a pulley. We all know what is a pulley. You can see in the picture. Correct? Now fix it at a height. Now draw a string over the pulley. Draw means not drawing. Draw over here means to pull. Okay? You have to pull a string over the pulley. Now tie a load of 2 kilograms at one end. Hold the other end of the string and pull it downwards to lift the load. Now first up to a height of 1 meter and then up to a height of 4 meters. Now what you feel when the more work is done? Obviously when it was up to a height of 1 meter, it was easy because you have to put less force. But when you had to take it up till 4 meters, you had to give more pressure, more force was applied. Correct? Now when the applied force is the same, more work is done when there is greater displacement. In other words, for measuring the work, both the force and the displacement must be considered. Got it? Now, moving to the next topic, that is the relationship between work and energy. Now students, I show you one picture on your screen, that is a boy who is pushing a car. Now students, the boy in this picture has applied a force to the toy car, correct? Now work has been done because the force applied to the car has caused displacement. In other words, transformation of the boy's energy is being given to the work which is being taken place through the applied force. Now same way, if you run around the ground with your friends, can your friends run as many rounds as you can? No, correct? Some will run 4 rounds, some will run 5 rounds, some will in fact run 10 rounds, and somebody will be tired even in only 1 round. So do all the friends have the same capacity for running? No, all the friends are not having the same capacity. Your friends will complete either more or less rounds than the number of rounds you complete. The number of rounds will not be the same. Some will get tired on completing 2 rounds, while others will get tired on completing 3 to 4 rounds. That is to say, each one's capacity to complete round is not the same. You can complete only as many rounds as you have the capacity for. The capacity to do work is called energy. Do you know, students, that the units of work and energy are the same? Work and energy are both measured in the unit named joule in SI system of units. Next is forms of energy. Students, there are many forms of energies like force and motions. Okay, the first energy is mechanical energy. Now, from its word mechanical, it is not that easy to be understood. Now I'll help you how I can explain. The mechanical energy is divided into 2 parts. The first one I'll show, that is what will happen as a result of the action in the picture. Basically, the rubber band is released after stretching it, correct? A stone is held in the rubber of a catapult. Catapult is this particular toy which this boy is having in his hand, is called as catapult. The rubber is stretched and released. In the above examples, we see that when the rubber of a catapult is stretched and released, it comes back to the original state, correct? And the stone flies off. This is what this catapult does. Similarly, when the spring of a toy is wound and then released, the toy starts playing. When water stored at a height is made to fall on a wheel, the wheel starts rotating. In each of these actions, displacement takes place, which means that work is done. From where is the energy obtained to do this work? The energy which is stored in an object due to a specific state or position of that object is basically called the potential energy. Understood, students? Now I'll explain you the second part of mechanical energy, that is called as kinetic energy. Now, going towards it, before starting, I'll let you try this. You have to take two balls. Let one of them stand stable at the center of a table. Now place the second ball on the table and push it so that it hits the first ball, as you can say in this pool game, correct? One ball is going to touch the second one. Now what will happen when the second ball hits the first one? Obviously the ball which is in front of the red ball will obviously move ahead, correct? From where did the second ball get the energy to set the first ball in motion? From us, correct? We are applying the force, that is, we are giving the energy. Now, in same way, in the game of marbles, from where does one marble get energy to set another marble in motion? Even while playing carom, from where does the striker gets the energy to make the pieces move? It is simple. We are giving the energy to the marble or the striker and set them in motion. The energy obtained from motion is basically called as the kinetic energy. The energy which is used for doing mechanical work is called mechanical energy. There are two types of mechanical energy, namely potential energy and kinetic energy. Potential energy is obtained due to position, whereas kinetic energy is obtained by motion. Understood, students? Now next we are having heat energy. So as from its name, heat, we understand that it is giving warmth. The earth receives heat in proper quantities from the sun. That is how an atmospheric temperature favorable to the living world is maintained. Heat is a form of energy. Sunlight contains heat energy. Heat is also produced by burning of fuel. Heat energy is used in the kitchen all the time. We can see we can cook food, we boil milk with the help of heat energy. Okay, students? Heat energy is used in kitchen all the time. Heat is measured in the unit called calorie. Understood? Now we also can try this. What you have to do is take a convex lens, or you can say that magnifying glass. You have to hold it over a sheet of paper in sunlight. Now move the lens in such a way that there is a tiny spot of light on the paper. Now hold the lens in this position for a while. What will happen? You will see that after some time the paper will start catching a fire because of the heat energy which is passing through the convex line and lens and reaching towards the paper starts the formation of heat energy. Now the next we are having is light energy. That is basically related to heat energy somewhere because light is being received through heat. So students, we have learnt that plants make their own food with the help of sunlight. It means that light energy is transformed into the energy in the food. Plants and animals use this food for doing their work. It means that light is also a form of energy. Understood, students? Students, here we end with the first half of our lesson. We'll continue with the next half in the next session. Till then, thank you.